Hello friends, we are going to study about the electrical machine 3 subject. So previously you have already studied the two subjects related to electrical machine, that is electrical machine 1 and electrical machine 2. So in electrical machine 1 we have studied about the DC machines, and in electrical machine 2 we studied about the transformers. In electrical machine 3 we are going to study specifically about the induction motors, and also we are going to study about it from the design point of view. Here we are going to study about three-phase induction motor and single-phase induction motor. So now we are going to start with the first chapter, that is three-phase induction motor. And the first point in the first chapter is introduction to three-phase induction motor. So let us start with this topic. So first of all, let us see what are the learning objectives. That is, what are the various things that we are going to learn in today's session. So the first point is, what is electrical machine? Then we are going to study about the law of conservation of energy, which you might have studied previously. We are just going to revise it. Then we are going to study about classification of various machines. Then introduction to three-phase induction motor. So let us begin with our first point, that is electrical machine. But before going to electrical machine, I would like to explain to you what is a machine. So a machine is any device which reduces human effort. So this is the summer season. We know that in summer season the temperature is very hot. So what we do, we just click one button and the fan starts. Or if we have air conditioners in our house, then we use the remote to turn on the AC, we get the cool air. Now these fans, air conditions, all these are machines. So these are the devices which are reducing our effort. If there was no fan or if there was no machine, then we would have to take some newspaper or the hand fan to give us the air. Now this was very tedious task because our muscles would pain, but because of the use of fan and air condition, this task is made very easier. So a machine is any device that reduces human efforts. Now this was about the machine, but we are going to study about the electrical machine. So what is an electrical machine? So basically, electrical machine is an electromechanical conversion device. So this is how it actually looks. So before going to electromechanical conversion, I would like to explain to you or just briefly revise the law of conservation of energy, which is very important. So what is law of conservation of energy? So the law of conservation of energy states that energy can neither be created nor be destroyed, but it can be converted from one form to another. And the total amount of energy in the whole universe remains constant. Now to explain this law better, I am going to explain to you a very simple example of the hydropower plant. We all know that hydropower plant is a power plant where the electricity is generated with the use of water. So basically in hydropower plant, the water is initially stored at a particular height in a reservoir. So when the water is stored in the reservoir, it does not have any motion. So it consists of potential energy. Now once this water falls on the turbines through the penstock, it gets the motion. So the potential energy gets converted into kinetic energy. Now see, initially the water was having potential energy. Now it has got converted into kinetic energy. Now let us see what happens further. When this water falls on the turbines, the blades of the turbines start to rotate. As a result, the initial kinetic energy of water is now converted into mechanical energy. This turbine is coupled to generator. So here what is happening? As the turbine is coupled to generator, the mechanical energy gets converted into electrical energy. And this electrical energy is used by us for various purposes. So see here, initially the water had potential energy, which then got converted into kinetic energy. Then it got converted into mechanical energy, finally into electrical energy. This electrical energy used for various purposes. So here the law of conservation of energy is satisfied. That is, energy here was neither created nor destroyed. Whatever energy was present in the water, it just got converted into different forms. And the total amount of energy in the whole universe remains constant. Now let us study about the classification of electrical machines. Before going to that point, I have explained to you initially that electrical machine is an electromechanical conversion device. Now, what is this electromechanical conversion? It means that it will either convert electrical energy to mechanical energy or mechanical energy into electrical energy. So depending on this electromechanical conversion, it is further classified as A, motor, and B, generator. Now let us see what is this motor and generator. So you can see here, this is roughly a diagram of motor. So it has at the input side electrical system, whereas at the output side mechanical system. In between there is a block which says electromechanical conversion. So we give electrical input and at the output we will get the mechanical output. So a motor is an electrical machine which will convert electrical energy into mechanical energy. Now let us see about generator. So here we can see for the generator, the input is the mechanical system, whereas the output is the electrical system. In between, again, there is the same electromechanical energy conversion device. So here we can say that generator is an electrical machine which will convert mechanical energy into electrical energy. So if we see in both these machines, that is motor as well as generator, one form of energy is getting converted into another form of energy. Mostly electrical to mechanical or mechanical to electrical. So we can say that electrical machine is an electromechanical conversion device. Now let us further study the brief classification of electrical machines. So if we see, electrical machines can be basically classified depending upon the type of supply. If it is a DC supply, then the machines are called as DC machine. If it utilizes the AC supply, then the machines are called as AC machine. Now again, DC machines are of two types, DC generator, DC motor. Now AC machines are again divided into two types, synchronous machines and asynchronous machines. Now you will be having a question, what is synchronous and asynchronous? So basically in case of synchronous machine, the machine rotates at the synchronous speed. Whereas in case of asynchronous machine, the machine does not rotate at the synchronous speed. So as we go further with our subject, we will understand the meaning of this asynchronous better. Now, synchronous machines are again further classified as synchronous generator and synchronous motor. Again, in synchronous generator, it is of two types, either single phase or three phase. Similarly, synchronous motor is also of two types, single phase and three phase. What we are going to study in our subject is this part, that is asynchronous machines, basically induction machine. Again, it is of two types, single phase or three phase. Our chapter is three phase induction motor. Now let us have a brief introduction about the three phase induction motor. Now as the name itself suggests, its name is three phase induction motor. So we get a very brief idea what this machine is from its name itself. So it will first of all utilize the three-phase AC supply. Then it will work on the Faraday's law of electromagnetic induction. And last but not the least, it will convert electrical energy into mechanical energy. That is why it is called as motor. So we can say that three-phase induction motor uses three-phase electrical supply. Then it works on the principle of Faraday's law of electromagnetic induction and it will convert electrical energy to mechanical energy. So the three-phase induction motor is considered to be a very popular type of AC motor. It is used extensively in most of the industrial drives because of the following reasons. First reason is it is very cheap. Second, it is very efficient. Third, it's very reliable. Next, it has a very good speed regulation. Then it has a very high starting torque and it requires very less maintenance. So these are certain properties of three-phase induction motor which makes it the best choice for various industrial drives. This is how a typical three-phase induction motor looks. As we go on further with our chapter, we are going to study in detail about three-phase induction motor. So this was about the introduction of three-phase induction motor. Thank you.